Okay, now we already went over how to use the special graph paper to draw a conic section. Today we're going to use a special graph paper to draw a conic section, and we're going to come up with a Cartesian equation, both in general form and center and radius form, by using the diagram. Now keep in mind, I'll try to do this without making any mistakes, but I found that doing these videos it's not perfect, and I made a couple of mistakes and I went back and redid it, but I can't keep doing that, so bear with me. Okay, again, the special graph paper, the center is the focus. Now our example, and you'll have homework like this, is going to be that we're going to have a focus at -1, 2, a directrix, the horizontal line y is equal to 6, and an eccentricity of 2/3. Okay, first thing we're going to do is locate the coordinate axes so that this focus is where it belongs. Now, seeing how the x-coordinate is -1, that means that the y-axis should be 1 unit to the right of that. So we'll draw a y-axis right there. And the y-coordinate being 2, that means that the x-axis should be 2 units below the focus. So we'll draw an x-axis like that. Now that puts the focus at -1, 2. Alright, now to draw the ellipse itself, keep in mind that the eccentricity is 2/3. So if I make a table, it's best to use D1 values with denominators of 3. That way this will provide an easy reduction. So if I put a 3 here, that'll give me a 2 for D2, 2/3 of 3, a 6 and a 4, and a 9 and a 6. That should be enough to see how this is all going to play out. Alright, well, let's go and use the special graph paper. Oh, before we do that, we do have to draw the directrix on the special graph paper. I just moved that just a bit, so I'm going to try to keep it in the line of sight here. So, let's see. 1, 2, 3, 4, 5, 6. We're going to have a horizontal line there. So, let's do the same thing we did first time around and use a dashed line for the directrix. Okay. That is the horizontal line, y is equal to 6. Okay, now remember how we did this. I'm going to move my, make sure I got this, kind of bump that thing. Okay, I'm going to lay my straight edge so that the one edge of the straight edge is exactly 3 units from the directrix. Okay, so that'd be 1, 2, 3 right here. Now remember how this worked. Every point on that edge is 3 units from that directrix. Now we're going to count out 2 concentric circles. 1, 2, and then I'll put points here and here. Those will be on the ellipse. Okay, well, hold on a second. I think I got that one in the wrong spot. Here. Okay, those points are on the ellipse. Now, we're not going to be able to find a vertex like we did the first time around. It's up in this area somewhere. But we'll try to deal with that later. Okay, so I'm going to slide to 6 units away from the directrix, but fortunately for us, we have the coordinate axis system. The x-axis is 6 units, so we'll take advantage of that, and we'll count out 4 concentric circles. 1, 2, 3, 4. All right. Now I'm going to move to 9 units from the directrix. Count out 2 more concentric circles. 1, 2, right about there. And right about here. Okay. And if I count 1, 2, 3 more, this will be, I'm now 12. I didn't write that on that, and this will be 9. That is a point that's right on the concentric circle. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. There is the last point on the ellipse. And you can see how it's shaped. Now, let me move this out of the way. The vertex is going to be up in this area, and we're going to have an ellipse shaped somewhat like this. It doesn't have to be perfect. Keep that. Okay. Do the best you can. Try to make it elliptical. All right, there it is. All right, now if I pick any point on this ellipse, let's put it about right here. Okay, I'm going to label that point x, y. That's a variable point that can be anywhere on the ellipse. Now, if I draw in what's known as, from what we know about the Focus Directrix definition, draw a line to the directrix that's perpendicular to that directrix, meaning that's the distance between this point and the directrix. That point will have a coordinate of x, 6. As this thing moves around, the x-coordinate will vary. The 6 will never vary. It's on the directrix. That is D1. Now, if I draw another, I shouldn't say line, I should say segment between this variable point and the focus, that'll be D2. Okay. Now, the focus is fixed at -1, 2, so this point is variable point. It could be down here. That could be D2, or D could be over here. If D2 was over here, then D1 would be this distance. Okay, so I will label that D2. Now, keep in mind that we started this whole process by saying that D2 is equal to ED1. Well, E in this case is 2/3. I'm going to replace it in there to try to not use too much paper. Well, it's better to use D2 squared, because we're going to use the distance formula, so this will be 4/9 D1 squared. Now, the distance formula, if you recall, is D squared is equal to x2 minus x1 squared plus y2 minus y1 squared. In general, and we sometimes put the square root symbol above that and use it as D, but it's better for us to not deal with square roots because we're just going to use the squares. All right, if I look at D1, x minus x, it's going to be 0, y minus 6. So D1 squared is y minus 6 quantity squared. Now D2, x minus -1 squared, y minus 2 squared. Adding those two together. So I got x plus 1 squared plus y minus 2 squared. All right, that is D2 squared. This is D1 squared. Okay, now if by manipulating this equation we can come up with the general form for this conic section. All right, first thing I'm going to do is clear the fractions by multiplying both sides by 9. And while I'm at it, I'll expand these binomials. Okay, so I'm going to multiply this side by 9, in which case this will get multiplied by 9, as will the y minus 2 squared. So this will be x squared plus 2x plus 1, and this will also get multiplied by 9, and that will be y squared minus 4y plus 4. And that's going to be equal to 4 times y squared minus 12y plus 36. Distributing, 9x squared plus 18x plus 9 plus 9y squared minus 36y plus 36 is equal to 4y squared minus 48y plus 144. All right, remember in general form, all of the terms have to be on one side of the equation, 0 on the other, and they're arranged from A through F, starting with the x squareds. All right, I'm going to save you the details and just go straight to it. 9x squared plus 5y squared plus 18x plus 12y minus 99 is equal to 0. All right, you can put that into congraph and look at it and you'll see this. Okay, but I also want you to follow through on this and get it into center and radius form. And how did we do that? Well, first of all, we factored the 9 from all the terms that are x terms. Factoring the 9 from the 9x squared, I get x squared. Factoring the 9 from 18x, I get plus 2x. Now, if I complete that square, I need a 1. The other side of the equation, remember that 99 is going to come over here, and I'm going to have to add 9 times 1. All right, I'll factor the 5 from the y squared term. Now, factoring the 5 from the 12y, I get 12/5 y. Completing that square. Half of that is 6/5, so we'll write 6 squared over 5 squared. That's how I complete the square, recall. And I will also have to add 5 times 6 squared over 5 squared. All right. Factor the binomials, x plus 1 squared, y plus 6/5 squared. That's equal to, all this stuff adds up to 576 over 5. Okay. Now, to get it in center of the radius form, remember it's going to end up looking like this. These things don't change. X plus 1, y plus 6/5. To get the number down here, remember what we did. We divide 576 over 5 by 9. That gives us 576 over 54, 9 times 5, okay? Because the 9 goes to the bottom. So, and then take the square root. So this is 576 over 54. And down here, I'm going to divide 576 over 5 by 5. That gives me 576 over 25. 576 turns out to be a perfect square. So the square root of 576 divided by the square root of 25 gives me 24/5. And there it is. And you should verify by looking at your diagram that these numbers are indeed right. And you can even put it into Desmos and take a look at it. And you should be able to find out if they are correct. All right, so for homework, if you look at section 10.5, problems 21, 22, and 23. Now, the book directions are going to be a lot different than what I want you to do. Okay, 21, 22, and 23, they identify conic sections. What I want you to do is with those conic sections, do exactly what I did here. Draw the conic section after taking the information that's given to you, focus, directrix, and eccentricity on the special graph paper. Then, use the focus directrix definition to come up with the general form of the Cartesian equation, and then go further and get it into center and radius form. Now, you may not have enough room to do it on the 3-graph paper. I wrote a little bit bigger than I normally would. But if you run out of space, just do it on the back. But draw all 3 on the 3-graph paper. So when you turn this into me, and I'll let you know how we're going to deal with that later, I'll be able to see it. Okay, until next time, thanks for watching.